Welcome to the intro to trigonometry. Now, I remember when I was little and watching Saved by the Bell, and they would talk about trig as if it was this crazy foreign language. It was rocket science. It was just so hard and nobody could ever do it. But that's just not true. In fact, trig is actually pretty easy. It's very relevant, and it's actually pretty fun. So let's just break this word down. It comes from the Greek words trigonon. And in Greek, trigonon basically just meant triangle. And metry, the Greek word metry, which just basically means measure. So we're just talking about measures of triangles, and that's something we've been doing for a while now. And it's all about ratios, which is why we spent the first unit recapping and reviewing ratios. It's all about the ratios of the sides and the angles, the two most important things in triangles. And there's three fundamental ratios that trig is based on: sine, cosine, and tangent. Now some of you are saying, oh shoot, those are the buttons on a calculator that I've seen, but I never knew what they meant. How exciting is it that we finally get to know how to use those? Okay, and so the sine of an angle, and this is going to look weird at first, but I promise it's going to all make sense in a little bit. Sine is not a number. It is not worth anything. It's not a variable. It's a ratio. It's a ratio of the opposite side to the hypotenuse. And so if we're talking about an angle, like if I'm putting my finger here on angle C, the sine of this angle is the opposite side, and opposite meaning across from it, the one furthest from it, not the ones that are touching, but the opposite one. And the hypotenuse, and you should know that the hypotenuse is the one always across from 90. And remember from the last unit that the biggest side is always across from the biggest angle. The biggest angle here is 90. So this is always the hypotenuse, and then here are the two legs. Now depending on which angle we're talking about, in this case, this one's opposite. If we're talking about this angle, this side is opposite. Okay. Cosine of an angle is adjacent over hypotenuse. So coming back over here, whereas the opposite leg is here over hypotenuse, adjacent would be the one that's touching it. Adjacent meaning next to. So this leg is adjacent over hypotenuse. And then lastly, the tan of an angle is opposite over adjacent. So just the different combinations of the legs. Okay? Still gibberish, I know. Let's keep going. I think it's going to make some sense. If you look here at this triangle, now let's make these numbers because I think it'll help instead of using letters. So I'm just going to make this a 3, 4, 5 triangle. And instead of putting the A out there, let's put the A here, and let's call this B actually. Let's call this B, and let's call this C. Okay? I think that's going to make it easier. So the sine of A, starting here looking at this first one. The sine of A, if we put a thumb on it, is opposite over hypotenuse. Now you may say, Mr. Rooney, how am I going to remember all of this? Well, there's different ways. But the main way is this acronym SOHCAHTOA. And before long, you're going to breathe SOHCAHTOA. We're going to say it so much, and you're going to remember it. It sounds like some sort of Indian tribe. It's not. It's just a made-up word, but it stands for sine, opposite, hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and then tan is opposite over adjacent. When I was learning this back in however long ago, well, we learned how to remember this. My teacher, and they actually told me this, is some old hippie caught another hippie. I notice the letters S-O-H. Caught another hippie. So tripping on apples. That's not really the word we learned, but we'll put it in there. Some old hippie caught another hippie tripping on acid is actually what my teacher taught me, and I always remember it. So if that helps you, it helps you. Or you could just remember SOHCAHTOA. Back to the example. So sine of A is up here. Sine is opposite. Now notice opposite is the one not touching my thumb right now. It's 4. Opposite is 4. The hypotenuse is always 5. So the sine of A is 4/5. The cosine of A is the adjacent one, the next to one, which is 3. 3/5. So we got 4/5, 3/5, and then tan, the third one being opposite, which is 4, over adjacent, which is 3. So it's the ratio of all the different sides. Now we have 2 angles here. Well, we actually have 3, but you can't do trig from the 90. The 90 is always there. If it's not a right triangle, you can't do trig. So we're only dealing with right triangles, and you can't do the sine of this one. So because there wouldn't be an opposite, the opposite and the hypotenuse would be the same thing. And 2 would be adjacent. But don't worry about that. Sine of B right now is down here. The sine of this would be opposite, which is 3, over the hypotenuse. Okay, so notice how the sine of the 2 angles are different. The cosine of B, let me put my finger back on B. Cosine is the adjacent one, which is in this case is 4. It's touching it, it's right next to it. The 3 is across from it. 4 is next to it, and the hypotenuse is 5. And then the tan of B is opposite, which is 3, over adjacent, which is 4. Okay? And you should start to notice some patterns here, and there's a lot of patterns, and there's so much to do with trig, and you'll learn all about the depthness of all that in pre-cal once you take it. But right now we're just focusing on the basics. Let's look at a real life example. Well, not real life, but closer to real life. We're looking to find x. Okay? And your first instinct may be, let's do the Pythagorean theorem. We only have one side. We don't have enough information. You say, well, can't we do what we did last unit? And, the angles got to add up to 180. Yeah, that's true. So we know that this has got to be 56. So is it isosceles? No. Is it equilateral? No. And so there's just not enough information to do anything that we've learned already. And so you have to do trig. And so here we're looking at this angle, and we could do it from that one, but let's just look at the one they gave to us. And so we put our finger on 34. Right now, we're looking for the opposite side, and we have the hypotenuse. So we have opposite and hypotenuse. Which one does that go to? This one. It goes to sine, looking at the acronym. So we're dealing with so right now. And so what we're going to say is that the sine of 34 is equal to the opposite side, which is x, over the hypotenuse, which is 10. Okay, now that we've set up this relationship, we're halfway there. Because we still need to find out exactly what x is. And so going back to learn how to solve equations, if we need to get x by itself, we need to get rid of this 10. And we do that by timesing everything by 10. And so we get that x is going to be equal to 10 times the sine of 34. Now you don't know what the sine of 34 is. So here's where we're gonna have to use calculators. And if you have a graphing calculator, it's going to be the best. If you don't have one, you can just leave it here. That's okay. But I'm just going to use this. And so we got the sine of 34. And for this calculator, different calculators are different, but I got to type in 34 first and then hit sine. So there's the sine of 34. And we want to take that times 10. And we get 5 point, and we'll just round to the nearest tenth and get 5.6. Okay? And so what we found is that because of this angle and this side has to be 5.6 long. Okay? let's look at the second one. Always start with the angle. Okay, the habit may be, well, we started here, and you want to do it again, but we don't have that angle. And so we're going to start here. Okay, and from there, we're looking for the opposite. We have the hypotenuse. Opposite, hypotenuse lets us know that we need to use sine. So the sine of 70 is the opposite over hypotenuse. And now this looks just like the last problem, even though the things were in a different position. You want to times both sides by 6. And we get that x is going to be equal to the sine of 70 times 6. So come over to the calculator, and I'll make sure you have calculators in class so that you can do these things. 70, this is really the only unit we really use calculators. The sine of 70 is this, and we're going to times that by 6. And we get about 5.6. That's a random coincidence. They're the exact same number. Total coincidence. Okay, let's look at this next example. Right now we have, here's our angle, opposite, hypotenuse, sine. Sine of 41 equals opposite over hypotenuse. So we have our ratio set up, and now we need to solve for x. Now the first thing you should notice is that in this one the x was on top. Now the x is on bottom, and it's a different ball game when the x is on bottom. Okay? And so we have to take 2 steps. Is that first we'll do just like we did before, and we'll times everything by x. But that doesn't get rid of x, it just ends up putting it over here. We have x times the sine of 41 equals 12. We still need to get x by itself. And in this case, we need to get rid of this thing. And so this is going to look weird at first, but what we end up doing is just dividing by the sine of 41 on both sides so that they cancel. And we're left with x is equal to the 12 over sine of 41. Really what just ends up happening from this original red is these two things simply switch places. The x comes up here, the sine drops down there. And this is something that I guarantee you looks confusing at first, but you're going to practice it so much that it's just going to become a habit. Okay? But then we need to do 12, divide that by the sine of 41. We get 18.3. Okay. And then let's look at one more example. Put our finger on the angle. Here we don't have the opposite one, we have the adjacent one, we have the one next to it, and we have the hypotenuse. So here instead of O, we have A, so that tells us use ka. So ka toa, we're using cosine. Cosine of 30 is 16 over x. Okay, again, x is on the bottom. So times it, and then divide by this thing to move it down. We want to get the x by itself. So they end up switching. So we have 16 divided by the cosine of 30. (16 divided by the cosine of 30 is 18.5. I don't know how these answers end up so close. But there you have it. Are examples of trig. Now on the back I have lots more examples, and if you need to, you can go to part 2 and just watch me do some more examples. I'm going to do some tan ones in there. But write down any questions you have. We're going to practice the heck out of it tomorrow. So come ready to work.